Welcome to my ramblings. This episode, circuiting part two and issues related to the National Electrical Code. When I accepted the offer of the job in Lant Div, um, I had flown out there for a job interview, and during the interview, they were asking me stuff. I asked them, I don't know, they asked me if no, I told them, oh, I didn't do any design work whatsoever at the Department of Interior. You know, the, the system was all built out. And so, like any utility system, sometimes you would have pole extensions and stuff. You know, you have to extend the power lines so that, and then install a service transformer, for new loads and stuff. And they had somebody that did that. He was a technician. You know, he had standard specs, and I was working on standardizing our stuff. We were looking at converting, or adopting the saltwater river project specs, or standard designs and what have you. And plus, one of the things that I was trying to um, condense down was, the number and types of conductors that we use. The conductors are overhead, and boy, you ever want to be called stupid? Walk into uh, an engineering office and start talking about how conductors don't have insulation, because in that industry, you know, overhead lines are conductors. Cables are when they wrap stuff together, and overhead conductors are usually bare, or they have a coating on them, which might look like insulation, but it doesn't serve an insulation purpose. The air is actually the insulation. It's more of a protective coating. Um, so that's neither here nor there. um, so I had accepted the job out there. They asked me my knowledge of the NEC. I told them I had limited knowledge of the NEC. I knew about NEC 220 or whatever the section was that covers load calculations. A couple of other things related to like protection of equipment and stuff. And the thing about the protection of equipment is, again, you have to keep it in context. What's the meaning and purpose and focus of the National Electrical Code? It's to minimize the risk of electric shock to people, safety, and to minimize the prospect of property damage that would occur if, if equipment was poorly installed or wasn't installed to meet the NEC. Then, you stand greater risk of fire, you stand the greater risk of people getting shocked and electrocuted. But so when people talk about something as protected per the NEC, it's totally different context when you're talking about protection of equipment. A lot of times, and when I was working in PwC San Diego, we had a mechanical engineer. And, we had equipment that was protected per the NEC. He was complaining about it because even though it was protected per the NEC, every time there was a fault that the protective devices had to interrupt, he still had to replace the motor. And, that will happen because, you know, it's a fire protection standard. It's a valid standard. It's a very, very important standard. But its purpose is not the same as designing um, an electrical system for a building, um, and ensuring that it's optimized for the operating conditions of the equipment. There's a reasonable assurance following the notes and stuff in the NEC. 3% voltage drop in branches, 2% in feeders, or vice versa. But unless you're looking at the damage curves of equipment and stuff, you can't assure that the equipment itself will be protected and that the equipment itself will be suitable for reuse. Probably don't have that problem many times, but it's just the way transient responses and just the way stuff is built. But so the other thing is there so underlying reasons for why things are. The NEC does incorporate theory, it has to, but it's also a learn as you go standard. In other words, you know, the NFPA came about because there were fires, and so they start investigating. Well, how do we stop this? There's loss of life, there's extensive property damage, and it might have been an insurance company um, uh, motivation that started this, but it didn't start off with the hundreds of standards that it has today. It started off with just a few, and it built up. And as situations were occurring in industry, these things were updated. In fact, the NEC is updated every 2 years to it, excuse me, every 3 years, and that's to address things that surface that you know people hadn't encountered. And there's also a constant evolution that isn't so much serious problem based, but people see improvements that could be made and they put in suggestions, and it goes through a process where these things are discussed and debated. And then if consensus is that this improves the standard based on what the standard's purpose is, then the standards get updated. Uh, so so there's underlying reasons for all of these things. And specifications are the same way, but that that one's going to be a long relative. That was a long topic too. But I'll introduce it by saying, when I was a cooperative education student, I was a GS Miscellaneous Engineering series, and I started off as a 4. I got college credits. My performance was good enough, so I was able to be promoted to a 5 and then on to a 7. But, I mean, it's not like I had to save the world or anything, to get a promotion as a student. And, 4 to a 5. It's not a big gap in proficiency and knowledge. And usually at the lower levels, it's, do you show a grasp of engineering concepts and stuff. But to get to the point, the issue, the sort of the introduction to the next video is, people for some reason were coming up to me and really just complaining about NAFX specifications and stuff. It's kind of like, really, they're bad, huh? Okay. I'm not sure if they expected me to do something about it or what they thought I could do about it, but that's the prelude to the one in which I discuss NAFX specifications. All right, thank you for tuning in.